what makes a bike unique, and that's the geometry. That's Rocky Mountain geometry. On certain bikes, you feel really good. Other bikes, you're struggling a little bit. When I got onto my 2.9er, it felt like I was getting back onto one of my old favorite bikes. The bike is stiff, it's light, but somehow I feel like I'm on top of my game, I'm carving new lines. It makes me a better rider. I'm inspired by the bike.
I feel a change is coming soon.
Monsters. Well, Dre brings years of experience and a lot of power and skill. That's really what we need to properly test these bikes on the North Shore. How's the frame? Does it feel stiff?
Oh dude, so stiff.
Really?
Yeah. It's unbelievable.
There's a lot of ingredients that go into a great bicycle. You know, most important is geometry. Frame stiffness is also critical. Of course, suspension performance. And once you have all three of those, I think you have all the pieces of the puzzle you need to go fast. So sticking with the Element platform, with the Element 2.9, we were able to build on top of a lot of learning that was made with the Element 2.6 platform. You know, engineering-wise, I think this is a good approach in that we're always adding into our pool of wisdom. So every new bike that we make is adding on top of work previously done. So as far as the process is concerned, we do a lot of finite element analysis, looking at the major load cases that the bike would see in a regular service. With carbon fiber, it's pretty neat because we can actually optimize what we call the envelope. And we understand that if you have a perfect envelope, that'll allow us to create the lightest frame possible. So once the computer design process is complete, we then go ahead and make an aluminum mule or a mock-up of the bike. One of the good advantages at Rocky here is our prototype lab and our ability to CNC parts in a timely fashion. We were able to really test our ideas out and ride them within, a day or two of conception. At that point, we test the sample. We have a 17-point structural test where we do everything from fatigue analysis to strength overload tests. This really helps us optimize the layup and determine how light we can actually make the frame. We then complete the 3D modeling on the computer and then make a RPT, which is a rapid prototype. And it's our first chance to physically hold the bike design in our hands and look at it in detail and decide if there's any changes we want to make before we go ahead and open up molds and make it out of carbon fiber. We can do everything except ride it, and that really makes sure that we have good clearance between all our suppliers' parts and our frame. At that point, we end up with a layup that we would call production or riding sample. We'll ride it under the team for a few months. Once everyone gives it a go, then we release for production. There's so much effort that goes into the design, testing, and development of a new bicycle. But really, at the end of the day, what matters is how it rides on the trail.